Hey everyone, this is going to be my last set of videos. We're going to go through a review sheet here, not covering the whole semester. I guess I'm counting on you to go back and use review material from the first two midterms to cover that stuff. Or here, let me shut the video off because it'll slow down my upload if I have the video on. So we're only going to have review problems from the stats half of the course. There are going to be 2 questions on the final, 2 out of the 5 that are on probability stuff. So you're going to have to go back to old review materials to brush up on that stuff. So basically our notes for today are a review sheet that I used last year for this class. And I just want to go through and work through all of these problems. So there's 12 problems here, and maybe we can squeeze 3 into each video or something like that and just sort of get through these and show you how they should be done. So let's jump right into it. First question, study of 420,095 Danish cell phone users found that 135 of them developed cancer. So let's find a 99% confidence interval to estimate the parameter of interest. So what does parameter of interest mean? Well, presumably you want to know what portion of the cell phone users got cancer. That's the parameter we're looking for. Parameter is sort of a fancy word for like the true proportion. So I'm going to do all of these questions in Minitab. So we'll just flip over to Minitab and plug these into the proper test. A big part of this exam is going to be figuring out what is the proper test to use. So the first thing I notice is it's a proportion question. The question that they ask, basically we know for each of these cell phone users, did they get cancer, yes or no? The information we have about them is not a number. So there's certain stat tests that go with categorical variables like that. There's the 1 proportion and 2 proportion test. There's the chi-squared test, and that's basically it. Every other test had, like, you had to be able to find a mean, and all the estimates were for means. So we're looking at a proportion question. We have categorical variable, and we have not split into groups. Now, you might think, oh, well, we split into 2 groups, the groups that have cancer and the group that don't. But the whole point of splitting into groups is that you then compare the answer to a second question between the 2 groups. And there is no second question. So this is not a 2-group question. We're measuring just one variable, cancer, yes or no. So it's a 1 proportion stat test. There's only one variable we're looking at. It's got to be a one variable thing. So if there's only one variable and it's categorical, you'd use the 1 proportion test. If your one variable is quantitative, you have number data for everyone, then it's going to be a 1 sample t-test. So I'm going to go into Minitab and use my 1 proportion test. So let's flip over there. And so new share. Bring up Minitab. We're going to do stat, basic statistics, 1 proportion. Okay, so I have summarized data. We know the number of events, the number of trials. So we had 135 out of 420,095 for 20,095. And we want a 95% confidence interval. Now, there's actually a second part. Number 2 is really a follow-up to this question, where they're asking you to perform a hypothesis test with a 0.034%. So here, let me just flip back to the Word document for a second here. So notice in number 2, it's referring to exercise number 1. It says the rate of such cancer is 0.0340 for those not using cell phones. Does it appear there's a higher incidence in cell phone users? So that's a hypothesis test. We want to compare the cell phone number with this data in question number 1 to this number for just sort of regular people, not paying attention to cell phone users only, of 0.034. So why don't we run both tests at the same time and do question 1 and 2 simultaneously. So 0.034, well, that's not in percent form. I needed to add a couple of zeros. So it was 0.034%. And in this box, we, 1% would be 0.01, 50% would be 0.5. So we need a couple extra zeros so that 0.034% is 0.00034 in proportion form. Okay, so I'm going to go with an alternative hypothesis of not equals here. And the way that question reads over on the Word document, it does make it sound like maybe you're looking for a higher number, and so your hypothesized proportion could have a greater than, just the way that it's worded. But I'm just going to always use not equals. That's our default, and it seems reasonable to just keep going with the default and say, well, my null hypothesis is that there's no difference for cell phone users, and the alternative hypothesis is that there's a difference, and then we could look at the actual proportion that happened to see if it's bigger or smaller. So we'll hit OK. This is our 95% confidence interval, 0.000269 up to 0.000380. That's my 99% confidence interval. My sample proportion is 0.000321, which is actually lower than that 0.0034. So we don't have a small p-value at all. It's very close. The numbers are very close. And if we had hypothesized that our alternative hypothesis was that it would be bigger, well, it actually turned out it was in the opposite direction. So we definitely wouldn't be rejecting our null hypothesis then either. So those are the two numbers we're looking for, 95% confidence interval. And then we have a p-value for number 2, where they ask for the hypothesis test. This is bigger than our standard testing level of 5%. So we do not have evidence of a difference for the rate of this cancer among cell phone users as compared to the general population. Okay, so let's move on to number 2. Or we already did number 2, let's move on to number 3. So a researcher is interested in knowing if there's an association between a score on the math placement exam out of 25 points and the student's grade on a basic knowledge quiz, like at the start of the semester. Some professors like to, after the students come into like Calc 1 with placement, they like give like a little quiz at the beginning of the year to check how much of like the pre-calc stuff they know. Okay, so I want to find the correlation R squared. So we have 2 numbers for each student here. We have their placement score number and their basic knowledge quiz number. So we're keeping track of 2 variables, and they are both quantitative. And we've only done one statistical analysis method where we have 2 variables and they're both quantitative, and that's linear regression. And that's also the only place we had an R squared number. So this is a linear regression question. We have to put these numbers into our table and run a linear regression. So unfortunately, they are, can I do a transpose? Please let me transpose this here. Data transpose columns. Okay, so it did let me transpose. So I selected all, I copy and pasted it in here. I selected it all, and then under data, I chose transpose columns, and then just selected all the stuff that I wanted to transpose. So I copied all the numbers in that were in on the question, and we're just going to run a linear regression. So stat, regression, fitted line plot. I guess usually we put the first number on the x coordinate and the second number on the y coordinate, which is annoying that it switches around like that. But presumably, like the placement test came first, and then this basic knowledge quiz is at the beginning of the semester. That came later. So, like, I like the x coordinate to be the thing that comes earlier in time. If you're in a situation where something comes earlier in time, you use the first thing to predict the result of the second thing. Okay, I think I'm just going to trust that all these options are what I want, because all I really want is the R-squared number. So here's our R-squared right here. It's 80.58%. So that's a pretty solid correlation. It's not over 90, it's not great, but it's not like the 30s that we had in some of our examples. And so here's the dot. These high scores are really close, and there's a bunch that are really close. There's 1, 2, 3 of them here that are pretty far away, especially these two are pretty far off the line. They're the ones that, like, if those two weren't there, then this probably would be a 90% correlation. But they're okay. They're in a pretty good line. And if we wanted a formula, then this is our formula here, that their basic knowledge quiz score is equal to minus 0.629 or 692 plus 0.6410 times their placement test score. And that formula is also up here at the top. So if the question had asked for the line of best fit, that would be it. And if we had a student where if we knew their placement test score, we could use this formula to predict what we think that their quiz score would be. And it would be a decent guess, like this 80% is sort of measuring how good we could expect our guess to be. Okay, so that's the first 3 questions. I think I'm going to do 3 questions for video to try to keep them all under 15 minutes.